just doing more practice with the 3 trigonomic ratios. So I don't want you to tell me right now, I just want you to think. What are the 3 trigonomic ratios that we learned yesterday? Just say it in your head. So there's 3 of them, 3 trigonomic ratios. Everybody think in your head for a second. All right, now talk to your group and tell them what the 3 trig ratios are. So we have the 3 trigonomic ratios, sine of theta, cosine theta, tangent theta. What is sine theta? What's our saying?
Oh heck.
Oh heck, and that stands for opposite over? Oh heck, another? And okay, adjacent over hypotenuse, opposite over adjacent. Very good. So then remember, from your picture, you'll go to theta, you know, straight across is the opposite side. So opposite side, and then straight across from the 90 degrees is your hypotenuse always, right? And then this must be then our adjacent side. So we are getting pretty good at that. All right, so let's go ahead and just practice. So here's my first example. I'm just going to do a couple, then really I'm just going to let you work. Okay? So find sine theta, cosine theta, tangent theta. So given theta, in this corner right here, notice we're given all the sides, so that's good. We don't have to use the Pythagorean Theorem to find anything. So we have sine theta, once again, cosine theta, tangent theta. All right. Oh, heck, another hour of agony. And then we go through and we just simply fill it in. So sine is opposite over hypotenuse, right? So 5 over 13. That is sine of theta. All right, and then cosine of theta is adjacent over the hypotenuse. So 12 over 13. And tangent of theta is opposite, which is 5 over adjacent, which is 12. 5 over 12. Then you'll look at your fractions here, 5 over 12. You'll look at your fractions and say, do any of them simplify further? If you don't know for sure, you can take your calculator, do 5 divided by 13, change it back to a fraction, and so on. These are all in the most simplified form. All right, let's do another one. Okay, so this one is another quite easy one, but I'm going to make a point so that hopefully I'm going to make a connection that's going to make maybe rationalizing the denominator a little bit easier. All right, so sine of theta, cosine theta, tangent theta. We set up the same thing. So sine theta, cosine theta, tangent theta. So, oh heck, another hour of agony. Let's go through and fill this in. So from theta, opposite, hypotenuse, and adjacent, right? Yep. So let's fill it in. Sine is opposite, which is 14. Now what is the hypotenuse, you tell me?
14 square roots of 2.
Okay, 14 square roots of 2. Now, looking at that answer, let's just stop right here. Can we simplify it before we rationalize?
Yes.
Yes, 14 divided by 14 becomes 1 over 1, right?
Yeah.
So what we have is 1 over the square root of 2. Now, what am I going to do to rationalize the denominator?
Square root of 2.
Good. I like that you say, Caden, I like that you say you multiply the top and the bottom to the square root of 2. Okay, so now everybody watch carefully. I'm going to hopefully make a connection for you. So we have the square root of 2 over the square root of 2. Now, once again, that's a fancy 1. That's why we're able to do it. And 1 times anything is just itself. All right, so on top, we have 1 times the square root of 2, which is just the square root of 2, right? Now, on bottom, technically, don't we have this? This is really going to help all of you out there. From now on, especially you advanced thinkers, I want you to try to think on this level. Isn't 2 times 2 the same thing as 2 squared? Yeah? Okay. So what we truly have here is the square root of 2 squared down here, right? Okay. So then think about it, guys. Squares, square roots, and squares cancel out. So what's left on bottom? 2. So we have the square root of 2 over 2. Now, you could have done it the other way. You could have said, I want to do the square root of 4, which is the same thing as 2 squared. The square root of 4 is equal to 2. Do you understand that you can do it both ways? Okay, awesome. All right, let's go on. So we have the square root of 2 over 2. I didn't really give myself very good room here. All right. I'm trying to debate on what to do. I might just bring my cosine down a little bit. All right, let's do cosine of theta. So cosine of theta is, Another hour. So what's our adjacent side? Quickly tell me. 14. What's our hypotenuse? 14 square roots of 2. Is that any different than the problem above? No. So what would our answer be? We've already simplified it.
2 square roots of 1.
The square root of 2 over 2. Are we all comfortable with that? All right, and then tangent of theta is another hour of agony. So of agony. What's my opposite side? What's my adjacent side? What's 14 divided by 14? 1. Okay, so there's our 3 trigonomic ratios. Okay. Last one, and I'm just going to let you work the rest of the day. So last one, then I'm going to let you work. Okay, so it says find sine theta, cosine theta, tangent theta. So given this right triangle, we're going to go through really quick, find sine, cosine, tangent. Well, since we're finding all 3, don't we need to know all sides? Yeah? Right? So we don't know this side. Let's go through and use the Pythagorean Theorem correctly, though, to find it. So the Pythagorean Theorem is side 1 squared plus side 2 squared is equal to the hypotenuse squared. So let's look at this one. Are we given the hypotenuse? Yes, it's an 11. That has to go on the outside. So 11 squared. Side 1 squared. I don't care if you call it question mark or 7. I'm just going to go randomly with question mark. So question mark squared plus side 2 squared, so plus 7 squared equal to 11 squared. Then we'll just solve for question mark piece by piece. So I'm going to subtract 7 squared. Subtract 7 squared. So then over here on the left, they add up to be 0. That's what inverses do, is they cancel each other out. We have question mark squared is equal to 11 squared minus 7 squared. Do it in your calculator. Quick, leave 11 squared minus 7 squared. You tell me what you get. 72. So we have question mark squared equal to 72. And then from there, question mark still not alone yet. What do we need to do? Square root both sides of the equation. Then our root cancels out our power, leaving us with question mark. Now, does 72 break down evenly? So take the square root of 72. It's a decimal, so we have to break it down by 10. What are factors of 72? 9 times what? 9 times 8, you're right. So I'm going to break it down into 9 times 8. Does 9 break down further? 3 times 3. 8 breaks down into 4 times 2, and 4 breaks down into 2 times 2. Then we're pulling out groups of how big? 2. Does anyone know why? Because it's the square root. Very good. So there's 2 2's right there, so they can leave the house. 2 3's right there, so they can leave the house. But this 2 must stay.
So if you're cubers, you need 3's.
Right. Very good. Yep. If it was a cube root, we pull out groups of 3's. Good connection, Justin. You're right. All right. So we pulled out a 3. We pulled out a 2, and left underneath was a. So we have 6 square roots of 2. Okay, so now that is just, all that work was just to find this side. 6 square roots of 2. And now we can do sine, cosine, tangent. So sine of theta is, oh heck, right? 7 over cosine is another hour. So adjacent, which is 6 square roots of 2 over hour, which is good. Do we need to rationalize that? Nope, it's okay. Roots can be on top. And then tangent of theta is of agony. So opposite over adjacent, right? I need more room. Quickly, we're almost done, guys. Opposite, which was what? Over adjacent, which was? Very good, Kaden. You're right. We would need to rationalize it. We cannot have a root in the bottom. Now, the 6 is okay. What's the problem? The square root of 2. What am I going to multiply by? So I'm going to do it to the bottom and to the... So on top, we multiply straight across. We have 7 square roots of 2. You can't multiply something outside of a radical with something under a radical. So you just leave it like this. 7 square roots of 2. And then on bottom, we're going to do it... I'm going to do it the advanced thinking way. We have 6 times the square root of 2 squared, right? 2 times 2 is 2 squared. So then, for this piece, our root cancels out our power, leaving us with 6 times 6 times 2, which is 12. So on bottom we have a 12, on top we have a 7 square roots of 2. Then, does 7 and 12 simplify further? No. So that would be tangent of theta. That would be our answer for tangent. Are we all okay? Okay, awesome. Now you guys, the rest of the time is yours. Finish 15 through 22. We have not learned yet how to factor in this class. That's actually our next unit. 23 and 24, you will not be able to do, okay? So So you simply will not know how to do them. But go up to 22 and have me check your answers as you go. Now, this is due at the end of the hour because I feel like you've had 2 full days. You should be able to finish this at the end of the hour. So, ready, set, go. Go.